All right, students. Well, what we're going to be looking at here in this particular lesson is something called a difference of squares. Now, this is another form of quadratic that we're going to look at today. And what you're going to notice with this quadratic is it's going to look a little bit different than the quadratics we've been looking at the past couple of lessons. Of course, past couple of lessons we have looked at solving quadratics with a leading coefficient of 1, which we had trinomials. And then we also looked at how do you go about solving quadratics with a leading coefficient other than 1, which typically are also going to be trinomials. So what I want to do is start off here, and this would actually be the answer to a difference of squares quadratic. Okay, this would be an answer to the difference of squares quadratic. So thinking in terms of whenever we have two binomials, just think, okay, well, whenever we have two binomials, what do I do in order to find the product of those two binomials? Well, as we talked about several weeks ago, whenever we multiply two binomials together, we use a method called the FOIL method. Okay, first, outer, inner, last. So in that method, as we go through, if we were to solve using the FOIL method, well, that would end up, now would give us 16h squared. But then we would have 4h times 3a, which would be plus 12ah. But then negative 3a times 4h, which is negative 12ah. But then finally negative 3a times positive 3a, which is negative 9a squared. Okay? All right, so that's what we would get whenever we multiply those together. But we know also whenever we use a FOIL method with two binomials, we're going to end up adding the two inside terms. Okay, we have like terms here. Now, what do we notice, though, in particular, about those two middle terms? Those two middle terms are opposites. Okay, we have a positive 12, we have a negative 12, so, and of course we have an AH for both. So when we add those two together, those are going to actually cancel. So what we end up with is 16h squared minus 9a squared. All right, so that would be our answer to, or that would be our product to the to those two binomials. Okay, so basically where you're going to start today, you're going to start here. Okay, you're starting at this point, and then you're going to end up at this point. So what would that look like? Well, the first thing we want to do, we want to, with a difference of squares. Okay, and these two words are very important. Okay, difference and squares. Okay, difference and squares. So it's important because with the difference of squares, as we also notice what is different from other binomials that we multiply together. Okay, typically when we multiply binomials together, we end up with a trinomial. But here, when we multiply these two binomials, we end up with a binomial. Okay, we end up with a binomial. And the reason for that is because as we noticed, when we multiply these two types of binomials, okay, which we actually have the same exact terms, but the only difference is we have a negative here and we have a positive here. So we end up with two opposites in the middle, so they cancel out. So that's why we end up with a binomial for our final product. So going back to, okay, how do I go through the process, and I'm going to factor this difference of squares. Well, first off, how do I know for sure it is a difference of squares? Well, number one, I see we have subtraction. Okay, that's one thing. Okay, we do have subtraction, so that's our difference. But then also, I notice that I've got two terms. Okay, so it's always going to be a binomial when we have a difference of squares. So here I do have a binomial. Okay, so I've got a binomial, I've got subtraction. But then finally, we also want to look at our two terms. Okay, our two monomials here, 16h squared and 9a squared. Those are both perfect squares. Okay, and so that's why it's called a difference of squares. Okay, this is a perfect square. This is a perfect square. So now I can find the square root. And this is the process that you go through. Okay, so I'm going to find the square root of those. Okay, so the square root of 16, which is 4. Square root of h squared, which is h. Then the square root of 9, which is 3. square root of a squared, which is a. Now this is the thing, we know that we're not going to have just one binomial, but we have two binomials. So the other binomial is going to be 4h plus 3a. We know it's plus because, once again, as we saw up here, okay, we did minus and plus. We cancel out those two middle terms, and we ended up with this, okay? So what we're going to do here, we end up with 4h minus 3a times 4h plus 3a. So these are our two binomials that we would end up with whenever we factor a difference of squares. Now, another very important thing to also keep in mind, okay, whenever you factor, remember always to look to see if you have a greatest common factor of the two terms. Well, in this case, we do not. Okay, so that's why we just started off. We said, well, I'm going to identify that it is a difference of squares. Once you identify that it's a difference of squares, then you can go through the process of finding the square root of the two perfect squares and set up your two binomials. Okay? All right, so let's take a look at another example. Okay, on the next example we have 121, okay, minus 4b squared. Okay, this is a b, okay, 4b squared, not a 6. So here on this one, first thing I want to do, well, I know I've got a binomial. I know it's subtraction. So since I have a binomial, I know it's subtraction. It's a possibility I could have a difference of squares. So let's take a look at our first term. Okay, first term is 121. That is a perfect square. The second term is also a perfect square because 4, the number, is a perfect square, but also b squared is a perfect square. So now, once I've determined that I do have a difference of squares, okay, once again, it's subtraction, it's a binomial, and the two terms are perfect squares. That is a difference of squares. So now I'm going to find the square root of those two terms. Well, what is the square root of 121? It's 11. Okay, what is the square root of 4? Of course it is 2. But then the square root of b squared, which is b. Now, once again, we know that we're going to have two binomials because this is always going to be a product, two binomials. So then my other binomial, very simply, same exact terms, this time, okay, that's a terrible looking b, but this time it's going to be addition instead of subtraction. Now let's say you started off and you did addition first. So you did 11 plus 2b times 11 minus 2b. Is that okay? Yes, of course we know that's okay because that it's multiplication, so that would just demonstrate the commutative property. Okay? So anyway, that would be your answer in factoring a difference of squares. That is your final answer. Okay, so let's take a look at another one here. Okay, actually, let's do this. I'm going to have you guys do a couple of examples, and then I'll show you the steps. Okay, the first one is 27 g cubed minus 3g. Okay, and the second example is b to the fourth minus 16. Okay, pause your video and work through those two problems. Okay, so what we have here, hopefully you paused your video and worked through those, and what we have here on our first one here, we have 27g cubed minus 3g. So I gave you this one just to kind of check, to make sure that you're finding the GCF. We do have a GCF on this one. Okay, we have a 3, which is a GCF of 3 and 27. But then we also have a g, okay, which is in common. So that would be our GCF of 3g. So when I divide those, that would give me 9g squared minus 1. So now, once I do that, I'm going to check to see if I actually have a difference of squares. Well, first thing is I know it's a binomial. Then I see its subtraction. But then I check my two terms to see if they are perfect squares. Okay, they are. So then I just very simply find the square root of those two. Square root of 1 is 1. Square root of 9g squared is 3g. So then we have, of course, we leave this out here, 3g times 3g plus 1 times 3g minus 1. And that would be fully factored. Okay. All right, then as we look at this one over here, and on this one, we end up with b squared minus 4 times b squared plus 4, because we do have a difference of squares. Now, this is the thing on this one. Okay, once I get to this point, let's take a look at this particular binomial. That is still a difference of squares. So we can factor that, and we need to factor that. So we're going to find the GCF, which is b. I'm sorry, we're going to find the square root, not GCF. Find the square root, which is b. Find the square root, which is 2, for b plus 2 times b minus 2 times b squared plus 4. Okay? All right, so that's how you factor those two. All right, so let's take a look at this one. We have 5x to the 5th minus 45x. Now, on this one, what would be your first step? Okay, we always want to look and check what? Do we have a GCF? We do have a GCF. Again, that GCF is going to be 5x. So we factor out the 5x, and we're left with x to the 4th minus 9. Now here, do I have a difference of squares? Well, it's a binomial. It's subtraction. The two terms are perfect squares. So yes, we do. So then we're going to factor that. So we end up with x squared plus 3 and x squared minus 3. Okay, can we still factor it? Well, let's take a look at the first binomial. Okay, it's a binomial with addition, so nope, no, we can't do that one. But what about this one? We have subtraction. It's a binomial. First term is a perfect square. What about the second term? It's not. Okay, so that's it. That's as far as you can go. That is not a perfect square, so that is fully factored. Okay, last one. Okay, let's take a look at this one. We got 7x cubed plus 21x squared minus 7x minus 21. Okay, so on this one, we have 4 terms. Well, what do we do anytime we have 4 terms in a quadratic? That's right, factor by grouping. Okay, so we're going to factor by grouping. So on this one, look at the first binomial, and then we are going to factor out a GCF, and that will be 7x. Oops, actually that should be 7x squared, Mr. Bowles. Yes, that's right. 7x squared. Okay. All right, so then, okay, once we factor out our GCF there, we're going to factor out our GCF on the other one, which is going to be -7. So that gives us, because remember, what do we want anytime we factor by grouping? We want the same exact term inside parentheses. So now we're going to have 7x squared minus 7, okay, times x plus 3. Okay, then for the first one, we're going to factor out a GCF. A GCF on that one, okay, because we do need to continue to factor. Okay, we actually have a GCF here we need to factor out, which would be 7. But are we done? No, we're not done, because what type of binomial do we have? That is a difference of squares. Okay, so that's going to be x plus 1, x minus 1, times x plus 3. And there you have it. Okay, that is fully factored. Okay, I have no GCF other than 1. I don't have a difference of squares, so that is fully factored. Okay, now just remember with equations, okay, you'll have a few equations to work on. Okay, just remember with equations, you got to set those equal to 0. Then once you set those equal to 0, you use the same principles of factoring, okay, that we did here. And then, of course, you're going to set up your binomials equal to 0 and solve for x. So it's just that extra step, okay, that you have to do in solving equations.